Hey everyone, another self-isolation bonus video where we take a blast into the past, looking at those old Pro Engineer features from the 1980s and 1990s that have been hidden in the interface. Today we're going to take a look at the Conic Surface and N-sided patch command, specifically the Conic Surface command. But before I do that, let me show you how to activate these different features. If you go to File Options Configuration Editor, then you can scroll down. You can add an option if you click the Find button. You're going to look for the option Enable Obsoleted Features. The default value is no, then you can change it to yes. And once you have it set to yes, you will be able to use the command search to locate those different commands. They still won't be in the interface by default. I've added them to my Common tab. I've gotten a lot of emails and questions about, hey Dave, how do I get that Common tab? Please check out my video on customizing the ribbon. In that video, I'll show you how you can use File Options and then Ribbon. And starting in Creo Parametric 4.0, they added this Common tab in there. You can check the box, you can create different groups, and then add various commands to the groups inside of here. You can change the icons, although I have not bothered to do that. So again, the Common tab is available in Creo Parametric 4.0 and later. The nice thing is if you add commands to the Common tab, they will be available in all modes of Creo Parametric for which it is possible. So let's cancel out of here. Again, let's take a look at this Conic Surface command. I will click on this and we will get a menu manager with a bunch of different choices of surfaces that we can create. In a previous video, I showed how to do the N-sided surface to fill in a patch of 5 or more edges. Here we will take a look at the Conic Surface command, and like the name says, we're going to create a surface where the cross sections have conical shapes. You have two different choices, either using your middle curve as the shoulder curve or a tangent curve. First, we will take a look at the shoulder curve option. I will click the Done button out of here. Then we get the model dialog box, lists the curves, and then here we have our conic parameter. In the menu manager, this is what you used to use to select the curves that you wanted. Let me turn off my datum plane visibility. I just had that displayed to sort of give you a sense of the orientation of the three curves in the model. So I've got these three curves over here. We're going to create our conic between two of the curves. So I'll select one curve, hold down the control key and select the other curve. Then I will change to over here. Instead of selecting my boundaries, now I'm going to select my shoulder curve, and then I'll pick this curve over here. And then when we click Done, Return, now it's asking us for a conic parameter. And the values are from 0.05, which is an ellipse, to 0.95, which is a hyperbola. This conic parameter, you can look it up. If I remember correctly, if you draw some asymptotes up to from the two different curves, and then where they intersect, drop another line down to the perpendicular intersection. It's the ratio of some of the different lengths in there. All that you really need to know is that with this conic parameter, at a value of 0.5, which is the default, the shape is going to be parabolic. If it's less than 0.5, the shape is elliptical, and if it's greater than 0.5, it's going to be hyperbolic. Due to the nature of the math, the minimum value that you can have is that 0.05, maximum value is 0.95. There is a special value, square root of 2 minus 1, which will give you the quadrant of an ellipse, which is a fancy way of saying it's going to be circular. And that square root of 2 minus 1 is equal to approximately 0.4142, or if you typed in SQRT and then 2 in parentheses and then minus 1, you would get the exact value of that square root of 2 minus 1. Then you would get that 0.4142 exact value for the normal of a quadrant. But let's go with that 0.5 value for it being parabolic. Now I can click the preview button and you can see a preview of the surface that's being created in between here. And if you take a slice of the different shapes inside of here, those conics would have that parameter of 0.05. Let's see if we can change this. Instead of 0.5, let's try a value of 0.1, and then hit the preview button, and we end up with a slight difference. I know it's hard for you to see, but you can see that outline there for a second. Let's change the conic parameter once more. Let's use a value of like 0.85, and then hit the preview button. You can see an outline where it's going to be much different than the value that we have right now for 0.1 in the preview. If I zoom in and zoom out, you can see how it ends up being a little bit sharper in here. So that was the first option when you're using this as a shoulder curve. One of the reasons that this isn't so necessary anymore is that you could achieve this with a boundary blend in one direction. You could also do this in ISDX with a loft, although you don't have control over that conical shape. If that is something that is important to you, you could use this feature for doing that. But let me show you the real reason behind this conic surface. I'm just going to hide the previous surface over here. Let's go to Conic Surface again, and then Conic Surf. Instead of a shoulder curve, I'm going to use the middle curve as a tangent curve. Let's click the Done button over here. And again, I need to select my boundary curves. I'll select this curve over here and that curve over there. Oh yeah, by the way, you don't have to hold down the control key. I'm just used to doing that, but it actually selected both of the boundaries, selecting them one by one. Now we will select our tangent curve, and I'll pick this middle curve inside of here, and then click Done. And now it's asked me for that conic parameter again. I'm just going to hit the check mark to take that 0.5. Let's hit the preview button, and what you'll notice is this time the surface isn't going through that tangent curve. This time what's happening is it's making, again, that word asymptotes. Say that 10 times real fast. It's creating asymptotes from each of the boundary curves through the tangent curve, and then it's fitting a conic in between those asymptotes based on the conic parameter over here. And again, right now I'm using a value of 0.5. Let's try changing this. Let's use a value of 0.1 and then hit the preview button. And you can see that it's going to be much flatter, much shallower in this particular case. Let's hit the preview button and then zoom in and zoom out. It's practically a flat surface over here. Let's change this again. Let's make this a value of 0.9 and then hit the preview. And you can see that it is inflecting much more than we had before. So that's the effect of changing the conic parameter. This had a real use back in the day when the round feature could not create conic shapes. It used to be that you would just have a radial shape, and sometimes you would want a smoother transition when you're creating a fillet in a particular area. Rather than using a radial fillet, you wanted a conical fillet so you wouldn't have such an abrupt change in curvature from a flat surface to the curved surface. That was the real point of this conic surface using the tangent curve option. Let me click the OK button out of there for this surface that is created in between there. But again, once you had the round feature that was capable of creating conic shapes with a row parameter, this was really not that necessary anymore. But again, hey, if you need the option of having this as a shoulder curve with that conical shape, this is one of those commands that you might want to keep in your back pocket. Anyhow, I hope you are staying home. I hope you are staying healthy. I hope you are staying safe. I want to give a shout out to our essential workers who are keeping society up and running while people like me have been self-isolating for over 80 days now by the time of the posting of this video. Thanks to our postal carriers and our package delivery people. Thanks to our sanitation workers. And thanks to our public works people who are keeping the water flowing and the electricity running. I hope you enjoyed this video. Thank you very much.